students. Welcome to the online classes of chemistry. Today we are going to start the first chapter of our second book of organic chemistry, which name is Haloalkanes and Haloarenes. I am instructing you all, please sit with one notebook and pen so that you can write it down what I am going to deliver in this lecture. And at the end of this session, I am going to give you 3 assignments based upon this. So, coming toward our chapter name, Haloalkanes and Haloarenes, today we will discuss about introduction of the chapter, classification on the basis of different modes, how we can classify haloalkanes and haloarenes, that is number of halogen atom, first classification. Second classification is based upon the nature of carbon, and the third classification is based upon the hybridization part of the carbon. So student, haloalkanes and haloarenes. Halo means halogens. And you all know halogens belong to group 17 elements, which include fluorine, chlorine, bromine and iodine. There is one more element, astatine, which we should not consider because of the radioactive nature of that element. So, halogens belong to group 17th element, and this whole part, alkanes and arenes, they are come from hydrocarbons. Hydrocarbons. So, we can say that haloalkanes and haloarenes are the halogen derivatives of hydrocarbon. They are halogen derivative of hydrocarbons. You all know about hydrocarbons. We have earlier discussed in class 11th also. So, let's recall the previous concept about the hydrocarbons. Hydrocarbons are broadly classified into aliphatic and aromatic hydrocarbon. In aliphatic hydrocarbon, there are 3 classes: alkanes, alkenes and alkynes, in which alkanes are saturated. Alkanes are saturated hydrocarbons and alkenes and alkynes are unsaturated hydrocarbons. So, we can also say that haloalkanes are the saturated aliphatic derivative of any halogens. And similarly, haloarenes are come from this aromatic compound, and we know that the best aromatic compound is our benzene ring. So, we can also say that the halogen derivative of benzene ring is called haloarenes. So, let me recall you the definition. The halogen derivative of aliphatic saturated carbon is called haloalkanes. And similarly, the halogen derivative of benzene is called haloarenes. In our day-to-day life, we come across these compounds like DDT, which is used in agricultural industries, As an anesthetic agent, there is one compound that is chloroform, formula is CHCl3, where the doctor is used as an anesthetic agent. They all are nothing but they all are hydrocarbons of the same halogen derivatives, which we are going to discuss in this lecture. So, haloalkanes and haloarenes are broadly classified on the basis of the different modes, which I am going to deliver you. So, classification on the basis of number of halogen atom. So today classification, first one is on the basis of number of halogens atom. On the basis of number of halogen atoms, haloalkanes and haloarenes are divided into three parts: mono haloalkanes, di haloalkanes, and tri haloalkanes. As the name suggests you, this classification is based upon the number of halogen atom. Mono means one. Halo means the same halogen, which is represented by X, and alkanes are the same derivative of hydrocarbons, that is aliphatic in nature. So, for example, if we consider CH3X, what is the name of this compound? It is methyl halide. Methyl CH3 and halide any of the X group. Either it's fluorine, bromine and iodine. As you can see, there is only one halogen atom attached to one carbon. If we increase the number of carbon, CH3, CH2, CH2X, here the number of carbons are increasing, but the number of halogen atoms are same. So, in this, the number of carbon is 3, but the halogen atom is 1. So, this is also called a type of monohaloalkane, because this classification is based upon the number of halogen atom attached, not the number of carbon. Same, you can prepare it for haloarenes also. In haloarenes, we have to make it as an aromatic ring. The same haloalkanes can be made it as haloarenes. So monohaloarenes means if one benzene ring contain only one halogen atom, then it is called monohaloarenes. So both the compound have at least one halogen atom to classify in the following manner. Second one is di. Di means 2. Halo means same X, and alkane should be the same saturated aliphatic hydrocarbons. For example, if I make 2 carbon of any ethene compound and put 2X and then satisfy the valency by hydrogen atom, what is the name of this compound? It should be ethyl dihalide. Dihalide for this 2 halogen atom attached in this carbon chain. So in this structure, you can see that 2 halogen atoms are present in 2 different carbon atoms. This type of compounds are called dihaloalkane, and same we can make it for haloarene. Benzene ring containing 2X atom to any of the X atom is called dihaloarenes. Coming toward the trihaloalkanes, tri means 3, halo means same X, and the alkane and then we can satisfy the valency by hydrogen. As you all know, they are called the hydrocarbons, means the compounds of only hydrogen and carbon. So in this compound, the name of the compound is propane trihalide, as because there is 3 halogen atoms attached in this carbon chain. So in this compound, as 3x atom are present, they are called it as tri-halo compounds. And I may ask you, can you make the same tri-haloarenes just like in this 2 compound? Whatever I have made, 1 halogen compound called monohalo, 2 halogen dihalo, and the benzene when contain when contain 3 halogen atom in any of the position, either in 1, 2, 3, 4, 5, 6, 1, 3, 5, whatever, it is called it as a tri-haloarenes compound. So this is the first mode of classification, how we can classify a haloalkane into its monohaloalkane, dihaloalkane and trihaloalkane. The second mode of classification is on the basis of number of carbon chains. On the basis of nature of carbon chain. On the basis of nature of carbon chain also, there are 3 modes of classification. First is primary, second is secondary, and third is tertiary. It is also referred as 1 degree, 2 degree and 3 degree. So what do you mean by this primary, secondary and tertiary structure? In a chain of any of the number of carbon chains, suppose CH3, CH2X, and in this I will give you the example of CH3, CH, X, CH3 and CH3, C, CH3, CH3X. Double covalent bond. Difference between these 3 compounds. What I have changed in this compound, if you can see, the X atom is attached to the carbon, which is further attached to only 1 carbon. There is no other carbon branching in the first structure. The X is attached to the carbon, which is attached with only 1 carbon. There is only 1 neighbor carbon toward the carbon atom. This type of structure is known as 1 degree, means the basic, the primary structure of the carbon chain. When you proceed toward the secondary carbon, then you can see the X, our functional group. If the X is attached to the carbon, which is further attached by 2 different carbon atoms. First carbon is this and second carbon is this. So the halogen is attached to the carbon, which is further attached to the 2 different carbon. Then this structure is known as secondary, means a secondary part of this primary basic structure, and which can further recoil and form this type of structure, which is complex in nature, and it is called it as a 3 degree structure. So what is the difference between these 2? This halogen is attached to the carbon and this carbon is attached to further 3 carbon atoms. This is number 1, number 2 and number 3. So here the halogens are deciding whether the structure would be primary, would be secondary or would be tertiary. So the halogen is attached to the carbon. If it is attached with 1 carbon, then it is called primary. If the halogen is attached to the carbon, is further attached with 2 different carbon, then it is called secondary. And if the halogen is attached to the carbon, which is further attached by the 3 different carbon atoms, then it is called as a tertiary structure. and this is based upon the nature of the carbon chain. The last mode of classification which we are delivering today is on the basis of type of hybridization. Third classification is hybridization, and you all know about hybridization, which we have already discussed in class 11th. So it may be a typical one to understand, but you should understand by the recalling the previous concept of the hybridization. If any carbon is bonded with the single bond, then the hybridization is sp3, and for double bond the hybridization is sp2. This is the keynote in which you are going to classify this on the basis of hybridization. So single bond is sp3 hybridized, double bond is sp2 hybridized. So classification is based upon the two mode of hybridization. First is sp3 hybridization. sp3 hybridization. In sp3 hybridization there are three classes. First is alkyl halide, because we are dealing with halogen only. Second is allyl halide, and the third is benzyl halide. You have to remember only one thing, that sp3 hybridized should be identified by any single covalent bond. There should not be any double or triple bond. So alkyl halide is simply known as haloalkane. Any alkyl halide, CH3, CH2X. As you can see, the halogen is attached to the carbon, which is attached to two different hydrogen, and this carbon is satisfied by single covalent bond, not a double bond, not a triple bond. So this single covalent bond decides the hybridization of carbon, which is sp3. So the halogen is attached to the carbon, which is sp3 hybridized. So this type of classification, this type of groups are called alkyl halide. What is allyl halide? This is new for you. Allyl halide means the halogen is attached to sp3 only, because our classification is based upon sp3 classification. So if I'll give you one example, CH3, CH, double bond CH2. And I ask you one question regarding this. In this compound, which carbon is sp3 hybridized? So think about it. In this compound, which is sp3 hybridized carbon, single bond is sp3 hybridized, means this carbon bonded with these two, means this is a sp2 hybridized carbon. This first one, second one, the third one. First and second both are bonded with the double covalent bond, and the third carbon is free if I write the structure like this, CH3. So this hydrogen is omitted and attacked by any halogen. So allyl halide groups are those in which halogen atom is attached to the carbon, which is next to the double bond. There are basic difference between alkyl and allyl. There is no presence of no double bond in this alkyl halide. But in this structure, double bond is always present. But we have to put the halogen atom next to the double bond, which is sp3 hybridized, means which is single covalent bonded carbon atom. So this is called sp3 hybridized based, and the class of the compounds are known as allyl halides. The last one is benzene. You all are right, benzene is derived from the word that is benzene. But the problem is, the benzene have double bond character in all the carbon. And I have told you regarding whenever a carbon having double bond character, then it is based upon the sp2 but benzyl, Y-L, they always contain the number of carbons CH2. So if we put one CH2 here, CH, CH, and then we add one X. Now you can see this carbon is attached to one more carbon, and this carbon is bonded with 4 single bonds. Means single bonds are always sp3 hybridized. So they are called benzyl halide. This is the third mode of classification that we are doing based upon the hybridization. So on the basis of sp3 there are alkyl, allyl and benzyl, in which halogen atoms are always attached with the carbon which is always sp3 hybridized in nature. Proceed toward sp2. Proceed toward sp2. There are only 2 classes. First is vinyl and second is aryl. First one is vinyl and second one is aryl. As you can see, it is sp2 hybridized, means the main motto is to add any halogen atom to the carbon which is bonded with the double covalent bond. So let's say for example CH2 double bond CH2. What is the name of this compound? It is ethene. So it's very simple. If you replace one hydrogen atom and add one halogen atom, then this carbon is attached to the other carbon with double bond. And remember this thing, that double bond containing carbon is always sp2 hybridized in nature. In earlier classification, I have put X in that carbon where the number of hydrogens are 4 and the hybridization is sp3. Here the halogen is attached to the carbon which is bonded with the double covalent bond. Hence it is called it as a vinyl halide. This group is called vinyl halide. Next, aryl. Aryl is again the substituent of benzyl ring. So as you all know, all the carbon of any benzyl ring, and we should also write it as, for more clearance, we should write it as a ring, so that you will notice that all the carbons present in the benzyl ring bear a double bond character in it. So if we put halogen directly in the benzyl ring, means this halogen is attached to that ring which is double bonded in nature. So based upon these classification of vinyl and aryl, both are classified in a form of sp2. And for sp2 you should remember that the carbon should be a double bonded carbon atom, and for sp3 it should be a single bonded carbon atom. This is the classification which is based upon the following hybridization of the structure. So let me recall it once again for you. Haloalkanes and haloarenes are the halogen derivatives of any hydrocarbon. These hydrocarbon may be aliphatic or may be aromatic. These aliphatic, which further classified into saturated and unsaturated compound, and we will discuss in this chapter about only alkanes. Alkanes means only single covalent bonded atom. On the basis of the haloalkane and haloarene, we can classify these carbonyls compound into 3 modes. First is number of halogen atom. On the basis of number of halogen atom, they are classified into 3: monohaloalkane, dihaloalkane and trihaloalkane. Monohaloalkane means a single halogen atom, whether the carbon chain is of 5 carbon, 6 carbon, whatever, but the number of halogen atoms should be 1. Dihaloalkane means number of halogen atoms should be 2, and trihaloalkane means number of halogen atoms should be 3. On the basis of nature of carbon, there are 1 degree, 2 degree and 3 degree. When the halogen is attached to the carbon which is further attached with only 1 carbon, it is called primary. When halogen is attached to the carbon which is attached with 2 different carbon, then it is called secondary. And when it is attached to 3 different carbon atom, it is called tertiary. And the last classification is on the basis of hybridization. Either this halogen is attached with sp3 or it is attached with sp2. So there are total 5 modes in sp3, alkyl, allyl and benzyl. And in the sp2 hybridized mode, it is 2 classification based on which is vinyl and aryl, in which the halogen atom is added with the double bond. So let me give you the assignment for this. Please make a note on that. Introduction part and classification I have finished in this session, and today's assignment is number first. Write the 3 structural differences between haloalkanes and haloarenes. Write the 3 structural difference between haloalkanes and haloarenes. Second, or this haloarene, which one has sp3 hybridized structure, and why? And the third assignment is, what is the IUPAC name? What is the IUPAC name for CH3, CHCl, CH2, CH3? Write the IUPAC name of the following. The 3 that I am going to give you today, and hope that you it and show me when we will meet.